In this video, I will discuss a question from ray optics. It's based on lens and mirror combination. First, I'll give some basic ideas. I have seen three sets of light rays. First one is like this. Second one is like this. The arrow mark indicates the direction of propagation of light. And third one is like this. So what is the difference between these three? First one is parallel beam of rays. So these two light rays will never meet. This one is convergent rays. Along the direction of propagation of the light, if you proceed further, it will meet somewhere here. So these are convergent rays. And this will never meet. So these are divergent rays. So we shall have some idea how to produce these rays. One way to produce parallel beam of rays is to use a convex lens and have object at the focal point, source of light. See, so the light will go like this. And come out parallel to the principal axis. This is the focal point. So this is the focal length of the lens. So this way I can produce parallel beam of rays. To produce convergent beam, I can reverse this direction. Convex lens, send parallel beam of rays. Will come out and meet the focus. So these rays are convergent rays. So one way to produce convergent rays is use a convex lens. Divergent rays, you can just have a point source of light. So light will go in all directions. If I just take two rays, this will give me divergent rays. Another way to produce divergent rays is using a concave lens. Concave lens is thin in the middle. Convex lens is thick at the middle. So to this concave lens, if we send parallel beam of rays, the light rays will go like this. It will diverge. So convex lens is called convergent lens because it can produce convergent rays given parallel beam of light. Convergent lens, and concave lens is called divergent lens. And we have converging rays. If you put a screen here, I can see a image of this object. But when you have divergent rays, wherever you put the screen, whichever position, there won't be any image formed in the screen. So this is a divergent rays will give me virtual image. Convergent rays will give me real image. So convergent rays will give me real image, and divergent rays give me virtual image. So with this understanding, we will solve this question. So this is a question: a convex lens of focal length 15 centimeter is in front of a plane mirror. The distance between the lens and the mirror is 10 centimeter. A small object is kept at a distance of 30 centimeter from the lens. The final image is A virtual at a distance of 16 centimeter from the mirror, real at a distance of 16 centimeter from the mirror, virtual at a distance of 20 centimeter from the mirror, real at a distance of 20 centimeter from the mirror. So to find the final image, whether it's virtual or real, and also where the image is formed, at what distance. You can pause and run this question. This is a straightforward question, but it's solved step by step. So there is a convex lens of focal length 15 centimeter in front of a plane mirror. This is a plane mirror. Obviously, it should be on the shiny side. Okay, at a distance of 10 centimeter. Okay, so the object is kept at a distance of 30 centimeter from the lens. So the object is here at a distance of 30 centimeter. So you find the image of this object. So the light from this object will go like this. It's a convergent lens, so it will come out like this and get reflected by the mirror and hit the lens again and still get further converged. So we can break this into 3 steps. First step is to get the image through the lens. So light will go here and form an image somewhere here. This is the first image I1. And this image will act as an object to this object and produce an image on this side. And that image I2 will act as an object for this second lens or lens for the second time and produce an image here. Okay, so for the first image by the lens, U1 is 30 centimeters. And you have to fix the sign. The direction of incidence is towards right. So for the first image, the right side is positive. Because this direction, positive direction should match the direction of the incident light, which is from left to right. So U1 is on the left side, so it's minus 30. And one result I can use for a convex lens when U is minus 2f, which is on the left side, V is 2f. This result can be proved easily using the lens formula. Lens formula is 1 by U plus 1 by V equal to 1 by f. And there is a minus sign here because U is on the left side. To make this term positive, you have to put the minus sign here. So in this, if you put U equal to minus 2f, I'll get 1 by 2f plus 1 by V equal to 1 by f. That means 1 by V equal to 1 by f minus 1 by 2f. That will become 1 by 2f. So V equal to 2f. This can be proved easily. So we can use this result if you remember that. So this means V1 is 30. Whose focal length is 15 centimeter. U1 is minus 2f. So the first image is formed at a distance of 30 centimeter from the lens. So from here to this one, this distance is 30. And this distance between the lens and the mirror is 10. So this distance is 20 centimeters. So this will form an object for this plane mirror. So the image due to this plane mirror will form here at a distance of 20. Already this is 10. So it will form at here. This is I2. Image at the second step. First step is refraction with the lens, I1, then will act as an object to this one, produce this image I2, and this I2 will act as an object for this one and produce image here, which is I3. For the third step, this object I2, the light rays is coming like this one. This one is producing this I2. Okay, so for the third step, the positive direction is towards left. Because for the third step, the light is coming from right side. So the positive direction should coincide from right to left. So if we get that convention correct, then for the third step, U3 is on the positive side. This distance is, I got V1 as 30. So 20 here, so 20, this is 10. from here to here. So I2 has a distance of 10 centimeters from the lens. So U3 is plus 10. And we have to find V3. I can use the lens formula 1 by U minus sin plus 1 by V equal to 1 by F. U is plus 10 plus 1 by V3 equal to 1 by F is 15. So 1 by V3 is 1 by 15 plus 1 by 10, LCM 30. So do 2 plus 3, 5 by 30 is 1 by 6. So V3 is 6 centimeters and it's plus 6. So this distance is 6 centimeters. So the object is a distance of 6 plus 10, 16 centimeters from the plane wave. And it's a real image because the rays coming here is convergent rays. So B is the correct answer. Distance of 16 centimeters from the mirror and the image is real. So B is the correct option. B is the correct answer. This one explained here. So this is the lens of focal length 15 centimeter. Object is a distance of 30 centimeters from the lens and plane mirror is at a distance of 10 centimeters. So the first object will produce a image at a distance of 30 centimeters from the lens because for a convex lens, we can use this if you at a distance of 2f on the left side, then the image will be at 2f on the right side. So use actually minus 2f here because the right side is positive. So if I use that result, I'll get image at a distance of 30. So that means that the image is a distance of 20 centimeters from the mirror. This will act as an object to this plane mirror. So this will produce an image at a distance of 20 on this side. This is 10. So image is the second step, which is I2, is a distance of 10 centimeters from this lens, which acts as U3 for this lens. So for the third step, the light is coming from right to left. So left direction is positive. So that means U3 is plus 10. That's an important step. U3 is plus 10 because towards left it is positive direction. And using the lens formula, and if you would U as plus 10, I'll get V3 as plus 6 centimeters and plus towards the left side. So image is formed at a distance of plus 6 from the lens. So the final image is a distance of 6 plus 10 from the plane mirror, and this image is real because it's a convergent rays coming here.